Hello, welcome back after a long period, but I was trying to design a new system for joints and whatnot. I had a problem, if I did just a fence like I was, and the initial idea was to have a fence on the router table. But then after I thinking, the thing started getting complicated, and the usefulness was very limited. So it was a lot of work and a lot of expense for a limited use. So I decided to change the idea. Well, the same idea, but a different configuration. Instead of the router bit coming from the bottom, and we'll have it coming from the top. So I had to redesign everything, and basically it became a computer numeric control, a CNC. So that's the more traditional, but with a twist, that I still can do the joints on the CNC. It's just not a flat thing, where I can do some carvings and some cutting, but also I can do the joints at the edge of the wood instead of being on the top of the flat part of the wood. So here is a machine. You can see I have basically a CNC configuration. However, at the edge I can put on this edge right here, the machine can forward enough, and you can see the bit where it's forward enough, so I can cut edges and do joints in it. Dove joints, finger joints, and whatever joint you want to do. Your imagination is your limit. But the thing is that you're not, with this machine, you are not condemned just to do the flat part of the wood, but you can put it up and cut your joints on it. So, with any further ado, let's try to do something down. Now, this machine is not a kit. It's not a commercial. This machine was built by hand, piece by piece. I bought some extruder aluminum parts, like I showed you in the last video. After I finished the prototyping on the router table. So this way I don't need my router table. I can leave my router table free. It's not it was convoluted trying to get the thing in and out of the router table, leaving to do things by hand because you were too lazy to get the thing out of the router table or put it back on the router table. So this way is a machine on its own. Instead of using a worm gear across this axis, I use a belt. So that way it simplifies the construction of the machine a little bit. However, that axis, going back and forth, yes, it's got a worm gear. And in other words, it's got a 3/8 all thread screw. Simple. To keep the cost down. All these other parts, all the other brackets and whatnot, there's plates and whatnot, they're cut by hand, tap, drill, whatever I needed to do to create the parts. Most of the parts are all, they are not, it's only one welded part, which is the nut is welded to the plate for the Y-axle, the axis. I keep on calling it axle. I don't know why, but it's axis. There's no axles here. It's an axis. Anyway, and you can see that all these parts are there. I use for the router right now. I'm using the Bosch Colt, which is enough. Well, if I have to change it, I'll change it. I have a wooden bracket out here that I made because I couldn't find a bracket that fit the Colt. However, I found finally this bracket. That is a little bit bigger than the Colt, but I figure if I put a few strips of wooden strips or rubber strips and harder rubber, Probably it'll fit. I had to experiment with this, you know. I'm not too convinced. I don't want the router to be rocking in there, moving. So you see, I don't want to spend too much time explaining. The only thing that is here that is expensive was the linear bearings that I use on the bottom here. There's a fully supported and no flexing after all the problems I had before, and that's it. All the electronics is the same as I was using before, so the motors are the same motors, although there's one more motor right here for the Z-axis to go up and down, and that's about it. I just tried the machine, you know, and it worked fine. So I just wanted to share with you that part. Here you can see the bracket, the bearings and everything, how the machine, how to mark it. We're going to cut from the stock angle. We're going to cut some more of these brackets. So I have this saw. This saw is cheapy from Harbor Freight, and I put a blade out here to cut aluminum. So I using the minus gauge, minus guide out here to make sure I'm a 90 degree. I'm cutting on a 90 degree. So I use the first one that I cut to cut the rest of them the same. So I use it for to gauge in my width. Now, these are the brackets I cut before to unite the two guides out there. So where this going to run back and forth, and these are going to be the brackets. Now I want at least two screws on each one to elevate. So I need to have 4 brackets. Maybe I can elevate it as much as I can. Then, what I wanted to do is to put a piece across, and then we're going to have this other piece where the mill motor hooks up to it. See, the mill motor goes out here, and this one moves up and down. That's the third axis. Okay, but it's got to be at least a few inches from there, because I'm going to have to I need the table to be lifted up so I can have the worm gear or the worm screw in the bottom, and then build your table. So this table is going to be at least this height right here. So therefore, if the table is at this height, so the mechanism for the worm gear is in the bottom, and that makes the carriage go back and forth. The X-axle, or X, Y, and Z. So the Y-axle has got to be at least this high. So what am I going to do is to put these as high as I can, and then put that plate across. Now I didn't decide yet if that plate is going to be aluminum or a plywood. I need to decide that yet. A 3/4 ply would probably be just fine. I don't see why not, especially if I put 2 risers on each end to keep it from springing back and forth. But this is the whole idea. You can see here I already assembled the Z axle with the motor and everything. So now I have to do the only thing I need out here to do is to hook up my Y axle and then the Z axle, and we'll be in business little by little. We want to manufacture our own parts. We don't have anything to purchase from other people, but you purchase the linear bearings, for the Y axle, the X axle. You see them here, and you can see these are actually the linear bearings. They are inside there. You can see all ball bearings, and they come and they go around that track. It's exquisite linear bearings, and not very big and not very heavy. They're extremely exquisite linear bearings. So, and not very expensive either. Came from Japan. I purchased 4 and I can't find any more. Maybe near future trying eBay again. But that was the I got lucky there. I should have purchased all 6 of them because that's what were left, and I just purchased 4 of them. The way I'm going to do this, because it's a little bit shorter than what I needed, was, let me put it in perspective here, so you can see the way I'm going to do this. Okay, now we have one out here where the slider goes from the top out here to the top out there. Now if I bring this side all the way out here at the end, let me see if it's visible. I apologize for having to move the camera. See, if you put it out there all the way to the end, and we start moving these, remember the center is right here between the two. If we start moving these, I can go all the way out to here. So that way it gives me a full motion if I offset it a little bit. Okay? Because if I put the 2 of them at the same, it won't give me a little bit less of a motion. So that way I lose the width. That way I lose the width of the bracket, the bearing. So by offsetting it by that much, I get it for one end. Remember, we're going to have the center of the board that supports this is going to be right here. So that way, right here. So it just gives me what I lose with a sensitive. Let me see a little bit further back. See, now look at the center of the board is going to hold this. It's going to be right here. So if I use this like that, what happens? It's going to be right here. So I gained this width. That's all. That's all I need to be able to increase the to increase the. So if you have the, now we're going to do it again. If we have this here is the center, right here is the center. So they give me the full width of that table. Thank you. I know I trying with this medium, whatever it is, medium density wood or whatever it is, but MDF, but I know it's not ideal for this kind of joints. But I don't have any other kind of wood at this moment that I can wreck like that, and plywood is about as messy as that. So what I'm going to do is I'm going to try it with this, just for a trial, and we'll see what we cut. If the cut is good enough, and the spaced and all that stuff. See if I made it right this time. Let me start the router and computer.
back to the original position. Okay, now let's take it out. Let me move let's take it out of the block. Let's see this. Tap it a little bit. Close enough for that. I can keep on. I build it a little bit too tight, but that's the whole idea on the machine. Okay. Well, the light is not that good, but you can see even in that kind of material, the MDF, the joint came out very nice after I used a little mallet to seat it. It's a little bit tight. I had to work on the code. It's still a little bit tight, but very nice for the. I tried on the other side first, but it moved. I didn't have it clamped tight, and it moved. So I tried again. I flipped the wood over, and I tried again on this side, and it turned out perfect. Perfect. I wish all my joints ever would have been turned out this way. no gaps and nothing. Very nice, very nice. I'm very happy with this machine. So now there you have it. We have a CNC, computer numerical control machine, and I have some other uses for it. You know, if we want to do some carving or some scribing, can make whatever as soon as I get confidence and experience, because I still green with this thing. Although I build it, that doesn't mean that I know how to use it. Okay, thanks. Now that's the image I'm going to try to cut. I cut a couple other things and it went right. This is the first thing I'm gonna cut that is intricate. Oh no, too much intricate. It's intricate enough. All right, let me put the camera on the side and I will start the Mach 3. All right, there we go. Okay, let me turn it. I don't have it in automatic yet, but I will very shortly after I get the right bracket and other things. I have the electronics put on this side of the machine. I didn't enclose it yet because I don't know if I'm going to add or subtract or change things around or change the board. One of these boards, they give me some trouble, so I don't know if I'm going to keep these boards or I'm going to change it for a different brand or something. But these boards, I bought all the boards, not the power supply that you see in the back. There with the green and white wires. Hold on a second. That's the power supply down there. Everything else but the power supply, it was about $130. So it's not bad. Although you pay what you get for, though. You get what you pay for, I should say. Now, the motors, the NEMA 23s, I don't know what that's the standard. That's the motor that's for the X-axle. And it's a NEMA 23. I bought a little timing belt. You can buy those things on 3/8, ½ inch. There's another NEMA 23 on there for the Z-axle. The Z-axle is the one that makes the tool go up and down. And there is one more motor there for the Y-axle. And that is driven by a little belt to worm gear, which is an old thread, a 3/8 old thread. So I had to, after you calibrate the machine, you choose where you want to do metric or you want to do inches or imperial, and then you calibrate it to make sure when you command 1 inch it'll move 1 inch, you know, or 1.5 inches or 1.25 inches. It's got to be exactly 1 inch. And then you do that with all the axles, all the 3 axles, axes. And then when you do that, you're ready to go. And that's the most important part of it. That's a crosshead. That's a gantry, what some people call it. I made a wooden holder for the router there. I don't know if you can see that. I made a wooden holder for the router because I couldn't get one for that size, but I finally found one. It's just this one is just a little bit bigger, so I figured I'd put a few wooden strips out there, or rubber or something, because it's not that much, and I use these. I might have